Hey there, everyone. And our next speaker, speaker number 2 at the OWASP Developer Summit 2021, is Aakash Shah, who's going to be talking about why all speed and no security make infrastructure as code a risky business. Thank you, Aakash. If you'll take it away.
Thanks. Thank you, Vandana. Thank you for organizing this as well. Hey everyone, I'm Aakash. Hey. All right. Sorry about that. There seems to be some technical issues on my side, but I think they're resolved. So hey everyone, I'm Aakash. I'm joining you here from Chicago, where it's early in the morning, and I'm really excited to see an audience from across the globe. So I am CTO and co-founder of Oak9. I've spent my career doing security architecture work, and these days I spend my time building capabilities around our security automation platform that focuses on scanning infrastructure as code. And my talk today is really about the challenges that security organizations face as more and more development teams, DevOps teams embrace infrastructure as code. And we'll talk about what security organizations can do to really adapt to this trend. And a lot of this will be based on lessons that I've learned over the past 5 years, working with a lot of companies and talking to customers on a day-to-day basis. So let's jump into it. So if you're not familiar with infrastructure as code, no worries. I will give you a very quick primer, but then we'll jump into the challenges and really focus on what we can do as a community to really address these challenges. So onto the primer. If we just think back 10 years ago, most of the companies that I worked with had 2 different organizations that were siloed and were responsible for delivering software. You had your software development teams and your infrastructure teams. Fast forward to today, and application delivery really has completely transformed. What you see today is infrastructure is now designed and delivered and managed as code. And that is what infrastructure as code is. It's the ability to manage and provision infrastructure through code, through automation. And this code is now falling under the umbrella of software development. And what you'll find is modern development organizations that have really adopted this trend treat this infrastructure as code in the same way as they treat their application code. And we're affording it all of the best practices that we've established over the last 20 years with regards to software development, agile practices to infrastructure. And this is allowing development teams to accelerate velocity incredibly. And we're seeing more and more organizations really approach infrastructure as code from a top-down perspective where leadership is actually keen on investing in these technologies, mainly because it drives better business velocity and provides incredible agility for their applications. It allows for development and ops teams, right? You can automate and simplify your infrastructure provisioning. It makes your application deployments repeatable, scalable, version controlled, as well as consistent. And at the end of the day, your applications become more stable. And depending on the infrastructure as code language your organization adopts, you can build these infrastructure as code designs in a somewhat cloud agnostic way, which allows you to then reuse some of the work that you're doing across potential multi-cloud use cases. And over the 5 years that I've been involved in this, really, one of the big trends that I've seen is, instead of looking at infrastructure as code as a set of configurations, really today, infrastructure as code represents the entire application architecture. If you look at, a given application, and its infrastructure as code, what you'll see is all of the different components that this application is composed of, how those components interact, how the interactions are governed, And your entire application architecture is now codified in these infrastructure as code languages. And the downside of this is that cloud native architectures, are complex. And well, let me talk about the positive first. The big benefit to development teams now is that now you can deliver your infrastructure in a very agile way, from release to release, from sprint to sprint. You can actually evolve your application architecture to meet new business requirements, to meet new customer requirements. And cloud native architectures inherently are built in a way so that you can continuously evolve them. You can keep adding new capabilities in response to new requests from your business. And what we're seeing is this infrastructure as code is actually changing a lot from release to release. The one challenge that this brings is, cloud native architectures are also complex. And so for a typical application, you might see infrastructure as code that ranges anywhere from 5,000 lines of code to 70,000 lines of code. And that complexity is really what drives some of the security challenges. Security teams overall have struggled to keep up with modern development practices. And infrastructure as code really exacerbates this, because now as a security architect, I'm faced with reviewing 30,000 lines of infrastructure as code when I may not have come into the industry really understanding or being an expert in infrastructure as code. So security organizations generally have struggled to keep up with this, and this is what we'll talk about today. And we'll talk about how security can better adapt to infrastructure as code. So let's talk about what we can do as a security organization to really keep up with modern development practices. And what I'd like to really talk about is, infrastructure as code really brings a unique opportunity to security organizations to leapfrog forward and achieve incredible maturity as an organization. And the opportunity here is really the fact that infrastructure as code, as I mentioned, is really a rich representation of that application architecture. If you are doing all your deployments through infrastructure as code, then that infrastructure as code is actually the truest representation of your application architecture. And when you look at that richness within that application architecture codified as infrastructure as code, what you'll find is all of the security considerations that you care about as a security architect. How does information flow from one component to the other? What are the rules that govern that information flow? How are components isolated and segregated from each other? How do we achieve network security in this architecture? How is the access control policy being enforced? How are my data protection objectives being met? How is communications being secured? So all of these considerations are entirely represented in this infrastructure as code. And so, as a security organization, this is a really unique opportunity to then assess this infrastructure as code to provide security guidance and really, shift left, as many of the talks today will talk about, and design security and compliance into your applications. And that's what I'd like to focus on. And one of the key areas that you'll want to focus on as an organization, if you're supporting infrastructure as code, is really focus on building security design patterns. Depending on the level of maturity of your organization, this is something you may already be doing, or it may be something that you've always wanted to do, but adoption of infrastructure as code should really be a big driver to invest in building security design patterns. And as you build security design patterns, there's a number of considerations that organizations typically go through. I'll highlight some of them. So one of them is really making sure that when you build these security design patterns, you are thinking about the coverage that these design patterns will provide. So what use cases are they going to cover? What misuse cases are they going to cover? When you're, I think something that Andrew said earlier today, if you're trying to build security in, right, if you're trying to give developers secure defaults, really you need to build these patterns in a way that they're developer friendly. You want to make sure that these patterns address your compliance objectives, address your regulatory objectives, as well as any customer mandates you might have as a business. And then, you need to make decisions on what's the right level of abstraction for this pattern. Do I want this to be technology specific, or do I want this to be agnostic? And a lot of this will be driven by your organization. For example, if you are a organization that is taking the strategy of deploying your applications in a private cloud versus a hybrid environment versus a multi-cloud environment or a single public cloud, that's going to drive a lot of that decision making of how reusable these security patterns need to be. And then composability. So you're going to build a number of these patterns. You're going to start building your catalog of patterns. And how do you compose these patterns to then support a particular application architecture, a particular application use case? And a big challenge here is building these patterns and building a practice that is producing these patterns for your organization is costly. It requires skilled resources, and one way to really address this, and this is where resources like OWASP are incredibly helpful, is to leverage industry standards bodies that have already done a lot of this work. So OWASP has a number of these patterns that you can easily find. Organizations like NIST here in the US, or even Cloud Security Alliance as an example, they're all building reference architectures, they're all building security design patterns. And so these are great starting points to use to then accelerate your practice. And one of the unique things about infrastructure as code is that if your organization is adopting infrastructure as code, you can now build these patterns just as infrastructure as code templates. And that's going to allow you to get this into the hands of your developers in a more meaningful way. Some considerations here as you think about it is, is this repository of infrastructure as code templates going to be centralized or distributed? One of the things that I see a lot is, in order to be successful here, you have to, as a security organization, you have to have a really deep partnership with your architecture and development teams to succeed. But if you're able to build out these patterns, you're going to have just tremendous value for a lot of your commonly used cloud resources. The challenges that you face in this space is really keeping up with cloud service providers. There isn't a single day where the major cloud service providers don't make changes to their feature capabilities. And so that's going to require, an investment to continuously improve your patterns, to continuously update your templates. Another challenge that you'll face is a lot of organizations are really shifting towards empowering developers. So developers are now taking ownership of the entire release management lifecycle, all the way from design to operate and monitor, and the feedback loop. So when developers have the choice to select their cloud service provider, to select their feature capabilities for their application, now your surface area grows and you have to build templates across all of these different capabilities, and that becomes a challenge. And that's where really leveraging tools sometimes becomes incredibly valuable. But part of building out templates is to have an established governance process in place. And I can't stress this enough. You have to have processes in place to really manage the life cycle of these templates, because as I mentioned, the second you build these templates, they immediately start becoming stale the next day. And there's depreciating value unless these are being updated, these are being managed. And so you want to build the right processes around this. You want to think about change management. The second that your template gets into the hands of a developer, they're going to tailor this. They're going to really adapt this to the needs of their application. And so how are you continuously updating your templates, and how are you then going back to those application teams to make sure that they're using the latest and greatest design pattern that template represents? And so the model around this and the types of processes you need to build is really going to be organization dependent, and you need to tailor these to your organization. Centralized approaches really work great for organizations that have adopted this cloud center of excellence model, or they have centralized DevOps teams, whereas distributed approaches work better for full stack development teams as well as cross-functional autonomous teams. A big part of this is to be able to get visibility into every change that your development teams make. and to that infrastructure as code. And so in order for you to get there, one of the big things you'll want to do is make sure that you are a part of that development lifecycle. Security organizations need to really engage early and engage as part of that software development lifecycle so that they are there to review changes to that infrastructure as code. And this goes back to, following some of the best practices that we've already established for software development. We want to make sure that we extend those same best practices to infrastructure as code, whether that's how we manage the life cycle of code, how we make sure that code commits are reviewed, how we make sure that all code requires a certain process to be merged with master. And so these processes are going to be incredibly powerful here, and you want to make sure that you're building those right processes so that you get visibility into all of these changes. And it's not just important to then provide these, kind of design patterns that will help you build design security and compliance. And you want to make sure that once deployed, this application remains that way, that it remains secure and compliant. And so drift management becomes another capability that you want to invest in, which is how can I make sure that I'm managing my drift from what got designed in infrastructure as code as part of this application architecture to what got deployed and over time how it evolves. Developers will often go in through the cloud console, make direct changes to your application architecture for a given application. So how do we make sure that, one, we limit that, we control that by putting the right security policies in place so that all changes always flow through your development pipeline, which is where you're going to invest your governance and audit capabilities in. And some of the challenges that you'll face here in really getting this visibility is there's going to be a lot of changes. As I mentioned, as your organization really truly embraces cloud native architectures, as your organization truly embraces infrastructure as code, you're going to see this infrastructure as code change from release to release. And the challenge with infrastructure as code, as I mentioned earlier, is that when you're making changes to that infrastructure as code, you're really fundamentally changing the application architecture. And architectural changes lead to inherent security design gaps in your application. And so when you're talking about inherent risks, it's important to make sure that your development teams are following the right design. They're following security best practices as part of that design. And so being able to ensure that the application is adhering to your best practices is going to be really important. And reviewing all the changes. And so, you will be able to, a lot of organizations that I work with, right, once they establish these processes are able to kind of, scale to their most critical applications. But then, kind of that's where you really hit some of the limits of most security organizations. And it's really important then to focus on automation to scale this to your entire application portfolio. And there's a number of reasons why that's important, but I think everyone here knows, and Andrew talked about this earlier as well. It's really important to make sure that we are staffed as a security organization. There's enough resources to actually support this kind of a trend. And the challenge we have in the industry today is that there are 1.5 million unfilled security jobs. There's incredible resource constraints for every single security organization. And there's a survey that I saw a few years ago that talks about in the industry today, there's one security professional to 10 ops folks to 100 developers. And so that is an incredible contrast, and security organizations can't possibly keep up with automation on the dev and DevOps side unless they invest in their automation, in their own automation, so that they can stay in sync. And a big part of really building this practice is going to be creating those feedback loops that let you continuously improve. And that means taking feedback from your post-deployment monitoring solutions, the reactive tools that you're building, your penetration tests and your risk assessments, and feeding that back to your ISE templates to be able to really improve those ISE templates over time. And then, focusing on feedback from your infrastructure developers. So surveying your infrastructure developers, really collecting feedback from them so that you're improving those templates. And overall, as you mature your templates, it's going to help your application development efforts across the board. And then, for any good practice, right, you want to set the right metrics that are going to help you achieve the outcomes that you want. And these are some of the metrics that I've found security organizations find useful as they go down the journey of supporting modern development practices. So the first set of metrics really revolve around how does security really improve the velocity of delivery. So we typically focus on risk management metrics, right, as a security organization, but really for supporting modern development, security really needs to be seen as a driver for velocity. And so the metrics that we select here should really focus on driving that velocity. And so an example of some of the metrics that you can measure here are really how well did you reduce the lead time to engage the security organization and deliver those security controls to that application? How much did you reduce the deployment time? And you can measure the before and after and see the continuous improvement in this metric. You can measure the defect escape rate from a security standpoint for security defects. And here, what you're really measuring is the ratio of defects that you're identifying pre-deployment versus the ratio of defects that you're identifying post-deployment. And what you should see, right, as you implement better and better practices in this space is that you are catching issues pre-deployment. You are really shifting left and designing security in so that you are not seeing as many issues through your reactive tools after the fact. And then you want to measure the burn rate associated with these security defects. So how quickly are you, addressing these defects? And then time to compliance. So if you're baking compliance into your templates, if you're really, integrated into the development lifecycle and designing security and compliance in, then you should be able to measure how quickly your application becomes compliant, and as well as identifying the mean time to identify and address defects introduced by changes to your infrastructure. So how quickly are you reacting to changes within the development lifecycle? You can also measure metrics around the quality of delivery. And here, I'll go back to one of the metrics that I just mentioned, right, which is you should really see a drop in fundamental design gaps that you're identifying after deployment through security assessments, through pen tests. You should really see a drop in the types of vulnerabilities that you see that are more design focused versus, let's say, code vulnerabilities in specific libraries. Another metric that you'll want to measure is how much are you reducing costs. And so if you are building security design patterns that are addressing your compliance, audit, and regulatory needs, then it should be easier for you to prove that you are compliant and prove that you're following the best practices. And that should really reduce the cost in terms of, how much time are your developers spending? How much time are you as a security organization spending to really address compliance and audit requirements? And then avoiding cost, which, this really becomes organization specific and what types of models your security teams are using. But you can look at, how much did you reduce cost by addressing specific types of gaps early in the life cycle. And a good metric to use here is, IBM has a metric from, late 1990s, but it still holds true, which is if you're addressing issues post-deployment, it is generally 100 times more costly than to address it in design. So as you're identifying gaps in the infrastructure as code early in the lifecycle, you can measure that by using metrics like that. And then, if your security organization has their own risk management models, you can use those models to then also measure, right, by catching issues early, how much do we reduce the risk of breaches and security incidents? And that leads me to really a broad framework that we can establish. And I would love some feedback on this, by the way, after the talk. Please comment in the chats, right? That we can use to really measure how ready you are as an organization, as a security organization, to adapt to infrastructure as code, as well as how mature you are And a lot of the things that we talked about, right? We have published design patterns and security reference architectures that our developers can pick up and use. Security is engaged early in the lifecycle. Security has governance over the software development lifecycle. We're following those same best practices that we're following for modern development, for application development, excuse me. We have metrics that are focused on supporting modern development, and those are the metrics that we're measuring ourselves by. Security engineers have training and they understand infrastructure as code languages so that they can partner effectively with the architecture, development, and DevOps teams to really build out these infrastructure as code templates. Security is plugged into that development lifecycle so that we are getting visibility into every change that's happening from release to this application architecture. And we have the ability to measure drift once we've designed security in to make sure that we remediate any issues that might address after the fact, that might be introduced after the fact. And then security is focusing on automation to scale, and to scale in two different ways. To scale across your application portfolio so that you are not just looking at your most critical applications or your most critical changes, you're really getting visibility across all of your changes. And then two, you're actually building automation that lets you push changes at scale. So as an example, tomorrow your organization wants to really shift towards TLS 1.3 as the de facto standard for all your externally facing load balancers. Do you have the ability to then really, through infrastructure as code, push that kind of change across all your load balancers so that immediately they are now compliant with your new best practice? And so hopefully this framework is helpful to you, and you can really measure yourself across a maturity scale and then establish your target in terms of this is where we want to be as a security organization to better support our development teams, to really help drive the velocity, not just focus on addressing security risks, but also focus on improving the business velocity and improving the business agility, and really security as a whole being more agile so that we can, in an agile way, improve the security of that application architecture. So I'm going to stop here, and I would love to open it up for questions. I'll open up the YouTube channel so that I can see the questions here because I had to close it earlier.
Thanks, Aakash. That was great. I'm glad somebody's starting the conversation on how infrastructure being defined as code is as important, as critical, as necessary to look at from an application security perspective as other source code is. It's an important conversation to have. I don't see any questions on the YouTube channel, on the stream. But if there are any, feel free to reach out. We have tweeted about this, so they will have your Twitter handle. So hope you'll get some comments there.
Yeah.
And yeah, thank you so much for your time.
Thank you.
And please do stick around. I know it's early morning there, but please stick around to see the rest of the summit. And I will be moving across to the other studio now, and I'll see you guys in a couple of seconds. Cheers.